my name is Mai, and I'm a student at Faculty of ICT Mahidol University. And today I'm going to talk about process scheduling algorithm, which is FCFS, or you can call first come first serve. So, let's start. What is process scheduling? The process scheduling is a process that allows one process to use CPU in order to execute instruction while another process waits for the previous process to finish execution. Like this picture, P1 is the first order that CPU need to execute instruction of P1, and the incoming task P2 arrived, and P2 has to wait for P1 to finish the task first, so the computer can run the instruction of P2. And next, P3. After P2 is finished, after P2 finish the instruction, P3 arrive, and the computer can execute the instruction of P3 after P2 finish. So, the goal of process scheduling is to make smallest waiting time for each process so it can execute faster. And to make it highest throughput and equal allocation of CPU to process and optimize CPU utilization. So, the first come first serve algorithm. Among all scheduling algorithms, first come first serve is the simplest one that we are going to talk about. And as the name, the process which arrive first, go first, and gets executed first. To make it clear, processes are executed by chronological order of its coming. So, to calculate the performance of the algorithm, we need to calculate average waiting time. Average waiting time will be used for every scheduling algorithm. The average waiting time is a value to test its performance. In other words, it is the average of the waiting times of processes in the queue, the process that wait for the scheduler to pick them up for execution. I can sum up into this phrase. Lower average waiting time, the higher performance of the algorithm. So, let's see the example. This is the first example. Assume that all processes arrive at T0 or they arrive at the same time. So, there will be a table that the name of process is allocated here and the burst time here. Burst time is the time that each process needs for execution. So, we have to make it into Gantt chart first. This is a Gantt chart because it will help you to visualize the process that coming into the process that coming in the order. So, P1 use 21 burst time. P1 use burst time of 21. So, you will need to write 0 and 21 here, so it will be the period of P1 to execute, and P2 needs 3. So, after 21 from P1, we add by 3 because it needs 3 to execute, so we write 24 here. And after that, the process P3 arrived at the same time too, but it needs 6 milliseconds to execute the instruction. So after 24, P3 needs 6, so it will calculate to be 30 for the ending of P3. So after that, P4 needs 2, so 30 to 32, that's it. So now we can have Gantt chart here. And then to calculate the waiting time of each process, look at this step. The waiting time for each process can be calculated by this. P1 is the first order, so it don't have to wait. It doesn't have to wait for anyone, so 0. And P2, they have to wait for, let me change the color, have to wait for this one. After P1 execute, so it will be 21. And P3 need this one. Actually, you can 21 plus 3, this one, or 21 plus 3, this one, or you can choose this one. It's the same. So 24. And P4 need, let's see, you can calculate from this one, the green color here, to be 30. Or you can add the sum of P1, P2 and P3, the sum of both time, so you can get the waiting time for P4. And to calculate the waiting time, we add together. And then divide by number of processes, which is 4. And we get, I don't have calculator, so I will copy the value because it's the same. That's it. This is the first example. And the second example is the process arrive at different time. So it will be a little bit harder, but it's not really hard, believe me. So we can go to it very fast, like P1, start at P0. P0 arrive at 0, and execute time is the burst time. Five. So we know that it arrived first, so they don't have to wait, so it's 0. And P1 arrived at 1, and execute time is 3, as you can see from the Gantt chart. This one is the time that P1 arrived. You can calculate by 5 minus 1, right? Because 5 is the time that P1 gets started to execute. So 5 minus 1. Or you can call that the 5 minus arrival time, which is 1, equal to 4. Next, P2 arrive at 2, execute 8. So this one is the time that P2 arrive. Sorry. It will be 8 minus arrival time, which is 2. We get 6. And then P3, the last process. P3 arrive at 3. And they have to wait for this time. So 16 minus arrival time, yeah, we get 13. And then we can calculate the waiting time, the average waiting time by pad together and divide it by number of process, which is 4, and we get about 20, 34, around 8 point something. So this is the second example. So let's see the advantage and disadvantage of this algorithm. The advantage of this algorithm is it's easy to understand and easy to implement. But the disadvantage is that the starvation. Because this method is non-preemptive, the process will run until it finishes the task, so there will be no kicking out of the process. So the short process, which are at the tail of the queue, have to wait for long. So this problem we call starvation. And you can see the example of first come first serve in real life, which is buying ticket in front of the counter. So the first person get the ticket first. Sorry, you can say that the first person can buy the ticket first and the second person arrive. So it will be in the order to get execution. So that's for the first come first serve algorithm. Thank you.